Algebra II 3.5a, find the slope of a line. Now, if you haven't seen the other previous videos for Chapter 3, you might get confused, but you can just click on this video's description and go to the links in the Algebra II playlist and find them and scroll down. So here we've got a picture of a car on a road going up a hill and a truck on a road going up a hill. The grade of the road is a measure of its steepness. It's the ratio of the rise of the road to every 100 feet of distance. That's how they find the grade. It's 100 feet of distance compared to how much the road is rising. And the grades are figured as percentages like 2% grade or 5% grade. If it gets over a certain percentage, it's too steep for the truck or the car to go up. Well, this is like the steepness of a graphed line. So you can look at this and see there's a line here, right, that it's on. Okay, so it's like the steepness of a graphed line. We can find the slope of a line by finding its rise over its run, or as its rise divided by its run. And the rise is the lines that change in the y direction, and the run is the lines that change in the x direction. So I drew a graph here, and we've got a pink line, and we can see the rise over the run. It makes a perfect triangle, like a 90-degree angle here. See that? And we can count the units of rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rise is a 10. And the run is its sideways measure. We can go 1, 2, 3, 4, 5 to make that perfect 90-degree corner. So we've got a rise of 10 and a run of 5. And we divide them. 10 divided by 5. So the rise over the run is 2. The slope is a 2. The ratio of 10 divided by 5 as the change in y to the change in x is the slope of the line. Now, we could take these ordered pairs, 1 and -6, and 6 and 4, as x1, y1, x2, y2. See, because that's the first x, so that's x1. This is the second x, so it's x2. That's the first y, so it's y1. That's the second y, so it's y2. And we can use these ordered pairs in a formula to find the slope of their line. So the slope is the rise over the run. It's y2 minus y1 divided by x2 minus x1. So we take y2, 4, and y1, -6, and we plug them in here. And then we take x2 minus x1, so we got 6 minus 1. We do the math. 4 minus a -6, when we subtract a negative, we add the opposite, right? So we're going to get a 10 over a 5. We divide it and we get a 2. And the m in this equation is a slope. So this is a linear equation in slope-intercept form. Y equals the slope times x plus that b is the y-intercept b. That's where it crosses the line on the y line. We talked about that a couple videos ago, didn't we? The m is the slope, see? The b is the y-intercept, where it hits the y-axis. So the slope is the rise over the run. It's the change in the y-coordinates over the change in the x-coordinates. So that means it's the difference of the y-coordinates over the difference of the x-coordinates. And we could do y2 minus y1 divided by x2 minus x1, see? Now, another thing that's cool about looking at these graphed lines is we can look at the lines and know if our answer is going to be a positive or a negative. If we have a graphed line and it's rising to the right, well, then the slope is going to be a positive slope. And if it falls to the right, it's going to be a negative slope, okay? And the definition of the slope is the slope m of a line is the change in y divided by the change in x. And this is the formula. M is the slope, and it equals y2 minus y1 divided by x2 minus x1. And the x1 and y1 and the x2 and y2 are any 2 points on the line. It doesn't matter which 2 points you choose. As long as x1 and x2 are not equal to each other, okay? They can't equal each other. And when we read the ordered pairs, we always read the ordered pairs from left to right. So in this graph, we would read the ordered pairs with the 1 and -4 first, and then we read the 4 and the 2. We don't read it, top to bottom or whatever. It's whichever one is on the left is read first, and then we read the one that's on the right. Just like on this one, here's a negative slope. We read this -4, 1 first, and then we read the 2 and the -3, okay? So to find the slope of this line, we plug in the values of y2 minus y1 and x2 minus x1 as, see, here's y2 minus y1. So we got 2 minus 4, and we got 4 minus 1. We do the math, and we get 6 over 3, 6 divided by 3, which is a 2. So this one has a slope of 2. And you know what? We could just count it also between these points. The rise is 6. 1, 2, 3, 4, 5, 6. The run is a 3. 1, 2, 3. 6 divided by 3 is 2. Now this one's got a negative slope. We see it's falling to the right, so we know it's going to be a negative slope. Whatever our number comes out to be, it's going to have a negative in front of it, right? So we've got -4 and 1, and we've got 2 and -3. So we've got our y2, which is -3, and our y1, which is a 1. We've got our x2, which is a 2, and our x1, which is a 4. So see, these get listed first. The y2, x2 get listed first over here, and then these are over here, see? We do our math, and -3 minus 1 is a -4, and 2 minus a -4, when we're subtracting a negative, we add the opposite, so we get a 6. -4 over 6 is, whoops, it's supposed to be a -2/3, isn't it? They're both supposed to be -2/3. Sorry about that. So we get a -2/3 slope. Now, it doesn't matter if we do the y2 minus y1 over x2 minus x1, or if we flip it around. We have to subtract the changes in the same order. So we could do it the way the formula says with the y2 minus y1, x2 minus x1, but we could also do it this way. We could do y1 minus y2, x1 minus x2. We just have to make sure we're doing both the numerator and denominator in the same order. You can't put x2 down here if y1 is up here, see? They both have to start with the same one. They both have to start with either the y2 and x2 or the y1 and the x1. We're going to get the same answer. If we do the other way around, we get a 1 minus a -3, see? And a -4 minus 2. That still gives us a -4, 6, which is still a -2/3, see? So it doesn't matter what order you do the subtraction in, as long as they're both starting with the 2 or they're both starting with the 1, okay? So that is the slope formula. And from the two ordered pairs from 2 points on a line, we can find what the slope is. We need 2 points and their ordered pairs to find the slope of the line, okay? And the slope is the same for any 2 points on that line. You could choose any 2 points, okay? It's just best to choose points that are directly where the lines cross, because like right here, if you choose a point like in the center here, in the center of the unit, that's a fraction, and you don't know if you're being precise or not. If you choose it right where the lines crisscross, you know you're being precise, okay? So our next video is 3.5b, and we're going to talk slopes of horizontal or vertical lines. And I'm going to add this video to the Algebra II playlist that you can click on this video's description to go to it to study. And there's going to be links to the Graphs and Linear Equations playlist for chapter in Algebra I, and for the chapter about relations and functions from Algebra I, that playlist is going to be in here, okay? You can just click on them and study, all right? Okay. I hope you're doing well, and I'll see you next video, and let's talk about how a horizontal or vertical line might not have a slope at all right? Bye.